Let me tell you the story of how I wasted like 3 or 4 hours today. I bought these little LD06AJSA little modules that were really cheap. Like $1 for 3 of them. And these are LED drivers that drive LEDs in parallel, that are wired in parallel. So it only outputs around 3 volts. It figures out the volts. You set the current with this potentiometer, and the voltage it figures out itself. Whether it's 2.5 volt LED or 3, it figures it out. You just have to get the milliamperes right. So yeah, that is the theory. But what I didn't know, I didn't know two things. First, you have to connect the V1 to CE if you just want to power on an LED. The CE pin is for PWM control, so fade in, fade out of the LED, which is nice, but I don't want to use that. So you have to wire it to V1. Okay, the whole circuit has a ground. Noted here. Does it go anywhere? Short answer, no. The instructions say that you have to connect the negatives, all the negatives of the LED power supply input. You connect it to the ground, and it goes effing nowhere. It goes nowhere. F. It just stays here. Even though the chip has a ground, as it turns out, as I researched it, this part is ground going to the pin 2. This is all ground around here and here. It's all ground, and all the other side of the PCB is ground. So naturally I thought they must have figured out how to connect the ground there. Yeah? Well, no, it's not connected. So basically you have to connect the ground to pin 2. And then everything came alive. I mean, instantly everything worked as it should. I connected the... Let me just show you. Can I show you? Like a lot of LEDs here. Let's zoom out. Like an array of LEDs. These are also wired in parallel. Yeah. And this is the one I actually made work. And instantly, when I plug this into a USB, positive, negative, negative, and the ground goes there. The ground goes there to the back of the chip and to the pin 2. Okay, that was the problem. I have to hardwire it like that. And this way, it just lights up, and I can control the intensity, brightness, whatever you call it. It can be controlled. Let me just show you really quick. Ooh, that's a bit hard. Where is my screwdriver? Do I need a screwdriver for that, or I can turn it with a drill bit? Let me just turn it down. That's the lowest it goes. And then up. Ooh, a lot brighter. So yeah, as you can see, it works. And all it needed was me ripping apart one of these. I ripped this one apart. Focus. Focus. I ripped off the chip to see that nothing goes to the ground. And yeah, basically just connected it all up and it works. And allegedly it can go up to 2 amps, I think. This little tiny little circuit right here. And you can power a lot of things with it. Even if you just want to make one light with an array of LEDs, or from the backlight of a TV, you just cut one of these off, connect the positive and negative, and you can have one of these with the lens that spreads light evenly. You can have a very good lighting, or like call it a night light. You can use one of these and have a night light that shines everywhere in the room, evenly, very good to the eye, and you can set the brightness of it. You can also play around with Arduino and replace the potentiometer with a controlled resistance, whatever. Control it with temperature probe, whatever you call it, that is usually 10 kilo ohms, and if it varies, if the temperature varies, it goes up or down. Or a photoresistor, that's also 10 kilo ohms. You can also have the light shine brighter or less bright in function of the light in the room. So a lot of things you can do with this little guy. I will probably leave a link in the description. I recommend this. I really recommend this, the cheapest ones. Because once you figure out, you make one work, you see where the faults are, where the designer didn't include some very important things. It's not a big deal. You just connect the wire there and you have a working LED controller. Also, what is really nice about these, that is underappreciated, that the chip actually soldered to the PCB, it can handle 1 or 2 amps, because even if it heats up, this is a heatsink. And voila, it just took a little solder and yeah, they made it cool itself. So, link in the description. This is good. What am I supposed to say about this that I'm forgetting? But yeah. Oh, I mentioned in another video what I'm mainly going to use this for. The Christmas decoration that is called fairy lights. Those are tiny little LEDs connected on 2 wires in a string. I have a 20-meter string of them. It was like $4 from AliExpress, and that's what I want to use it for. Just put it outside in a transparent tube that I also bought, so it will be weatherproof, and this will set the actual brightness and life of the LEDs, because if I can decrease the amperage, then the LEDs will last a lot longer, hopefully. So with one tiny little thing, maybe it won't even need like a watt. I'll have decorations for whole winter, and maybe I'll leave it out even in the summer. Why not? You need some brightness, some lights every day. So, yeah. After 3 hours, 4 hours, it's kind of good that I figured it out, because I almost threw them away. But yeah, always research the stuff online and go for the data sheet of the chip. If you look at that diagram, you will instantly know if something is not connected right, whether the chip is soldered backwards or anything else. You can instantly know and correct it or return it if you don't want the hassle of correcting stuff on this really cheap stuff. So yeah, that's it for this video. See you next one.